Just get some
I know, I saw Winter.
random person saying something like, you know, you don't know how to teach this shit, or I can't see what you're writing. And I'm like, you're not a student of mine. Shut the hell up.
You make this so hard.
Good thing you don't have me then. So I want to show you something. There's a lot of there's a lot of misunderstanding about correlation. So here's a really silly example. I go out and I'm doing a study about height and what affects height. And as I'm walking to the lab, I walk by a park and there's some people playing basketball. I'm like, holy shit, they're all really tall. Basketball makes you taller. Interesting. I'm going to play some basketball so I could become taller. Now that's a really dumb example, but there's obviously a relationship between the height of a person and their likelihood of playing basketball, right? Now, you got beautiful people like Muggsy Bogues that gave me a lot of hope. Anybody know who Muggsy Bogues was? No? You're like, is that a gangster from the 20s or something? Spud Webb? Any Spud Webbs? No? You should Google this. You should watch these kids. 5'7", he could dunk the damn. And so when you watch him, you're like, whoa, that's weird. And even Muggsy Bogues, I think he's 5'3". Gave me a lot of hope. And, you know, not enough hope. Sorry. So I want to, well, let's see. I'm going to figure out where to bring this into this discussion because it's kind of nifty to see. There it is, okay. So I'm going to talk a little bit about the idea, and then I want to bring in some nifty stuff from the internets. So obviously, now this is not real data. I didn't have my class try this out. I don't recommend you do either. But you would expect there might be an effect. And I've shown you like the homework sheet with the little blue dots and so forth, and then we talked a little bit about correlation, so there seemed to be an effect. And I felt pretty good about saying, I think there's got to be some effect, the homework of having on your grade. But the height in the basketball playing is a really good example. In the real world, we got to be careful about, do one of these affect the other one, or is there something else that's affecting both of them? You guys kind of with me? So, for example, say that teachers' pay increases at the same time that the number of drunk driving incidents increases. So would you say that giving teachers more pay causes more people to drive drunk?
How many of them are teachers?
No, probably if teachers... Say again?
I said how many of them are teachers?
How many of them were teachers? Oh, well, that's a good point. But see, that's you'd have to look at that too, right? But if you just look at those two, that's one example of what... I don't know if you're trying to be funny totally, but you had a really good point. That's one reason we see correlation where there shouldn't be, is we don't even know if any of these people are in this group, right? But if the pay of teachers went up and we saw at the same time drunk driving, and actually if we followed it and they kind of like followed each other, would that necessarily mean that one affects the other? Not directly. If teachers' pay went up, very likely everybody's pay went up possibly, right? So then everybody's able to afford more alcohol, able to go to the bars, able to, you know, does that kind of make sense? Maybe they can take some time off work, they go to get some drinks, and then they're stupid, so they go on the road, right? Okay, everybody can be stupid. All right, so this one, so they go drinking the night before. You got a very early class, so you probably don't want to do that. You would expect, now another thing with correlation is the number of beers you have the night before the only thing that will affect your grade? No, I like it. Obviously, I'd hope studying and homework and all that kind of stuff would come into play too, right? So, which one of these, so does everybody understand, as the number of beers increases, what do the grades seem to do? Now, real quick, who's this person? Did they have a lot of drinks?
No.
No.
Someone who does.
But they didn't make a very good grade. So this person is probably someone who, no matter how many drinks they had, they ain't going to do good because they just don't get it. Who's this person? Drank a lot. And I don't know, hopefully you don't have to drink a lot to do better. Does anybody ever get better at pool after you had a few drinks? A friend of mine did that. I'm like, I kept trying, don't give him any more. Don't give him any more. But that's the person that really knows his shit and is able to hold his alcohol, maybe doesn't get as bad of a hangover. So those are kind of like outliers, right? So if I take them away, it might be easier to see. Overall, the trend is obviously a downtrend, right? As the number of beers increases, the grade went down. This one is a much more definitive correlation, right? So which one of these correlations would you say is stronger? This one's stronger. I like it because the points do what? There's a couple right answers here. Why is this one stronger than that one? Because here the points. Yeah, what do they all do? They all line up. I want that word line to come out of. So it's closer to being a straight line. So if I try to draw, taking these guys out because they're weird. If I try to draw like an average of, that's a horrible attempt. That's my first attempt. But I try to draw a line that represents the average position of all the points. I call that the best fit line. It's a lot easier to draw this one because they almost all line up on a line already. Let me stop there for a second. You guys getting so far? We're obviously not all the way into it. Just feeling this out. So there seems to be two things I want to be able to do with the math we're going to get into. I want to tell how strong a relationship is. How strong is the correlation? That relates to how close the points are, how tight they are to the line. And secondly, I want to know what the hell the line is. What's that line? Why would I want to know what the line is, necessarily? So what if I'm like, all right, well, I'm going to have this many beers. What grade can I expect? Well, if I knew what the line was, I could just plug it into the line and see what grade to expect. Is that definitely the grade I'm going to get? No. But the stronger the relationship, the better the prediction will be. All right, let me let all that sink in. All right. Now, of course, there's limits. You can't actually predict anything outside of the range of your data. Here's another silly example. You watch a fish, because you ain't got much of a life. You just sit there and watch a fish grow over time, and you plot the growth, and you're like, let me predict in 3 years, my fish will be eating Manhattan. So obviously, what's wrong there? What's wrong? You watch the little fish, it's like, oh, it's bigger, now it's bigger, now it's bigger. Let me plot that out for 2 years, and it's going to be the size of a whale. I got to get a bigger tank. What's wrong with that? What's going to happen to this? Is it going to be a straight line forever? It's going to hopefully slope off, right? You guys understand? So you can only live within your data, because the minute you're outside of your data, I have no idea if it's going to suddenly turn. It's the mistake people make with the stock market. Oh, let me buy some stock because it looks like it's going to go up. See, it's turning, and then the next, oh shit. And so you can't make predictions outside of your data. All right. Maybe. So, and then we already answered this question. That's the stronger relationship there. Which one's more realistic, though? Yeah, this one's more realistic because I expect to have outliers. I expect other factors are going to come in and affect things. So that's going to make the relationship between just beers and grade be weaker. Because somebody can have the same number of beers, but they studied more, so they should get a better grade no matter, does that? Yeah. Or somebody really can't hold their alcohol at all, so it doesn't matter how much they study or not. And then I just give one more. So would you say this is a positive or a negative relationship? Negative. Definitely negative, because the slope is negative. I like it. That thank God, that makes sense. I know slope. Don't change that shit. Okay, I won't. I'll give you one more example for a positive relationship here. So the number of hours that people study versus the grade they make on the test. So that, of course, would be the one that's more realistic. This person probably doesn't know what study means, right? And then this person, that's the person you just hate. Did you open your book? Nah. What'd you get? 98. You know, some of you are looking at people right now. Leave them alone. They're just jealous. All right. So again, which one shows a stronger relationship?
That one.
Yeah, the first one, right? That shows a stronger relationship. But this one is what probably would happen in the real world, right? So which one would have, whatever the number is we're going to calculate, which one would have a larger number? Because the number I'm going to calculate measures the strength of the relationship. So obviously, which one's going to have a bigger number than if it measures the strength of the relationship? It's going to be this one. I like it. Yeah, left. Thank you. Okay, let me stop there for a second. So the way we put the formula together, we forced the range to be from -1 to 1. So when we calculate the score, we standardize it so the answers come out between -1 and 1. 0 means no linear correlation. So it could be something like, so just no correlation would be something like this. I mean, there's just no freaking correlation. As one goes up, the other one goes insane. It's just... You guys kind of with me? But, I need some more paper. Here we go. What about this? What if I said this was how high I can jump versus how tall that tree is over there? Right? So I jump and I look at the tree. Like I jumped this high, the tree was this tall, and then I jump. Whoa! Oh, shit. Alright, still that's all. I mean, so it's going to end up being like this, isn't it? Of course it is. Is that a line? Yes. But would this be linear correlation? As one variable changed, the other one didn't give a shit. So this is an example of still 0 correlation. Does that make sense? So just because it makes a line doesn't mean it's correlated. This is completely not correlated. One thing is changing like crazy, the other one is like, I don't care. So they're not correlated with each other, right? And of course it could also work if I had one that was straight up and down. Because now like the y variable is changing and the x is like, I don't care. All right, how are we doing? Okay. So thankfully, 0 means no correlation. That's nice. -1 means perfect negative correlation. What do you think that would mean? All my dots would decrease, but if it's perfect negative, they would have to line up perfectly. They would all be on the line. The minute any of them go away from it, I would maybe get a -0.9, -0.8, -0.7. I keep pulling them away from the line. I like it. So an R of positive 0.9 would mean that my points are increasing and they're almost lined up perfectly. They're just not quite. So it would be something sort of like, maybe this would have 0.9. Positive. Why is it positive? Because it's increasing, and they are pretty tight to a line in the middle, aren't they? So maybe that would come out to be 0.9 or so, or 0.85 or something like that. You guys understand? So if I had one that was like this, bam, 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 that would be 1. That would be an R of 1. Because they all are perfectly on that line. It's perfect positive correlation. If that happens, you're like, what did I do wrong? Because that never happens in the real world. Okay. So this is all about the thing we're going to calculate that measures the strength of the correlation. And we call this, do I put it down here? The correlation coefficient. There it is. Here it is. Here we go. Correlation coefficient, or the Pearson product. And of course, my teacher's name was Pearson, but he didn't have a damn thing to do with this, but he likes to pretend he did. And the symbol we use for it is the letter R. So if I knew R was 0, what would I know?
No correlation.
There's no linear correlation. I like it. So I keep saying linear because this would have correlation. This has some kind of correlation here, right? That data there. It's got like quadratic correlation. It's got it's a parabolic correlation. But we're not going to study that. So does this have linear correlation? No. So this R would be really close to 0 for our analysis. But you can do stuff like cubic, natural log, logarithmic correlation, power correlation. You can do all kinds of crazy-ass correlations. We're just going to stick with linear correlation. Okay. And then finally, we talk about the line of best fit. The closer to 1 or -1 that R is, the more we trust the line of best fit to make predictions. Because the more they line up, the more I can trust that's going to continue. That trend is going to continue like that. Or in the middle, I can trust that it's going to meet that line. Any points I kind of predict for. Okay. So, that's all the idea behind this. Let's sink our teeth into an actual problem. We're going to do this first one together. So if you don't have a calculator yet, you might want to grab one. I'm going to try to do this. Here, let's see if this will show up nicely. So I tried to make a set of data that kind of matches the... I can't remember which one this is now. I think it matches... Let's graph this and see what it matches. I can't remember which one. I think I matched this one. Well, let's find out. So what do you think I'm going to do with this data? I'll tell you what to do with that data. No way. I'm going to put them in list 1 and list 2 because then I can calculate stuff about them. So just take a minute if you want to play along and put them into list 1 and list 2. Your lists are a little bit larger font than mine, which is good. Just to prevent anybody from doing this, definitely don't freaking sort anything. Hopefully it's obvious why. You want to maintain the relationship. Yeah. So just a little hint. As I do this every now and again, when I type in a number, I'll make sure it's ending up with the right other number. What really sucks is when you get to the end and the lists aren't the same size, you have done something wrong. Oh, thank God. All right. By the way, this is a little outtake from that calculator Bible that's up on the website. If you haven't printed it out yet, this is just specific to linear regression. That's what you call what we're doing here now. Okay. So it sounds like the typing has died down. So everybody's with me now? The lists are the same size? If they weren't the same size, that's pretty obvious. That's a problem. Somebody had beers and just didn't make it. Well, then don't count them. All right? They're still at home. Oh, well. So here's what you do. And this is the one place. Let me show you. Let me show you what the formula looks like. Please tell me you guys have it in here. Where's your formulas? These people. Today would be like, oh, yeah, I know. All right, here. All right. I used to make students do parts of this, but it's just not conceptually helpful. There's the formula for R. Can you begin to understand the work that we go into doing this? Okay, that's the last time we'll look at that. But notice something. These parts at the bottom look like standard deviation. So, and that makes sense because this is a sort of two-dimensional standard deviation in a way. We just jimmied the numbers so they'll come up to be between -1 and 1. But this still kind of gives me an idea of how spread from a middle the data is. Isn't that what a standard deviation does? So it makes sense that we have standard deviations kind of showing up for the x's and the y's. And then, I don't know if you saw, there's a mixing of The x and y's, that makes sense too. We want to see how they work together. All right, so there's stuff in the equation that I would expect. So that's nice for it. We're not going to use it. So here's what we're going to do. So now I've got my data in there. I want to calculate something to do with my data. So I want to go to stat calc. Now I like that I can see both of these options on my screen. Which option makes sense for what I want to find?
Regression.
Yeah, see how there's two of them?
Yeah.
If you scroll down, I have no idea why they hardwired. You're like, I don't like A. I don't want it to be the slope. I want B to be the... I have no idea why they hardwired this in. Some of you guys are like, what are you even talking about, Jeff? If you could do this, why would you need it? If A is 7, here B would be 7. Why do you need both options? Right? If somebody's so, no, A can't be the slope. All right. So we're going to use number 4. So we're all on the same page. Just use number 4. The only one that should exist. So if you do 4, now if you get the newer calculator, it's going to do this. If you have the older calculator, it's just going to show up lin reg on the home screen. You can just hit enter because it defaults to list 1 and list 2. Me, I got to make sure it says list 1, list 2. Don't worry about this other shit. And then I want to calculate. Okay, beautiful, beautiful. All right, let me stop there. Don't worry. Hopefully some of you guys have more than that. Does anybody have more than that showing up? Only one person wants to admit it. I know more than that too, and it's beautiful. The rest of us suck. We have to get there. Does nobody else have more than that show? Anybody need help? Are you stuck with your calculator? Is that what's happening? Are you guys, is everybody to this point?
Yeah.
Yes.
Yes. And most of you only have A and B showing up?
Yeah.
Okay, sure. Okay, I can deal with that. That's fine. So all of us right now are going to do the following. And if you have your own calculator, you never have to do this again. It just turns on the switch that only does one thing that I know of. It shows me R. Right now, what do I know? Which is parts of the line of best fit. Right? So that's the line that would best fit my data. But I don't even know if I could trust that line until I know what R is. That tells me the strength, how close the data points are to that line.
I got R. I just did it. I'm sorry.
Oh, you're okay, Ash. I'm like, you lied to me. Okay. All right, so for the rest of us. So go hit, you never have to do this again. So I'm not even going to explain what the hell's going on. You do second 0 to go to catalog. And the really kick-ass thing in general about catalog is it's every damn thing the calculator can do. Everything. Holy shit. So that's a big list. So we got to get down to section D. Thank God to get there quickly, I can just hit the button that's got the letter D on it, above it. So I think it should be x to the negative 1 for everybody. See, there's a D up there?
Yeah.
So if you just hit that button, bam, it'll go down to the D section. If your R is already showing up, you don't have to do this. You're golden. Let me stop. There's everybody with me there that wants to be. Yes, yes?
No.
Where are you? Okay. Oh, so right now you can see it. Should be. Oh, now just hit root. We'll go down. Okay. Everybody else cool? You can calculate the day of the week. I've never even used that function. I have no idea. Whenever I do this, I'm like, oh yeah, I want to try it, and I forget. I'm like, I don't know what the hell I think that's. So if you scroll down until you get to diagnostic on. Stay with me now. Now, what diagnostic on does is it does what I want it to do, and that's all I'm going to say. Ha. You ready? Then you just hit, is everybody there?
Yeah. I know.
Huh? Oh. And then you hit enter. Enter. And it's just going to say that. That was very anticlimactic. Is everybody there? Does it say done? And I go to stat, calc, number 4 again, the lin reg. Bam, 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 bam. And now everybody should have R squared and R shown up. Now, even given how little we've talked about this, what do you guys think about that R value? What couple things does this R value tell me?
It's pretty close to 0.
It's really close to 0, right? And 0 is no correlation. So this is, at the most, this is very weak negative correlation. Does that make sense when I say that? Because 0 means no correlation. It is negative, and it's really close to 0. It's much closer to 0 than 1. In this case, negative 1. So that's very weak negative correlation, if there even is correlation. Yes, sir?
So if it was like -1, that's a higher correlation?
Yeah. If you want there to be correlation, -1 and 1 are your good values. -1 it means they perfectly line up, they just happen to point out. +1 means they perfectly line up, they just happen to point up. Yeah.
What is the R-squared value?
So right now, R squared is silly. It's sort of like variance, and then you take a square root to get the useful number. When we go back to chapter 11, variance is finally going to have its day, and we're going to go, oh shit, that's what variance does. We don't know that. So R squared, unfortunately, let me give you the really short explanation. Holy shit. That was freaky. The cat was like, I'm tired of waiting for it. So we're not going to get into R squared a lot, but it's very interesting. Like I said, what affects your grade? Give me some factors. The number of beers you had last night, that could possibly affect your grade. What else could affect your grade on a test? How much you study, homework, attendance is crazy. Yeah, all this stuff. I love it. Wearing your lucky socks. I forgot my lucky socks. Right? That goes into the psychological aspect. R squared gives me an idea. Let me see if you guys get this. This is not important because I'm not even going to test on it. But it says 11% of the difference in the grades can be explained by the number of beers that I drank. So it gives me an idea of the relative effect that the one factor I'm looking at right now, number of drinks you had. I just had to show you how to drink. The relative effect it has versus possibly other factors. So if I do another analysis on grades and I do study, the number of hours you studied, and this is like 53, then that's the one that has the majority of the effect, right? That's a big factor. So if I want to increase my grade, I would focus on increasing that, on doing something about that. The number of beers thing apparently doesn't have as much of an effect, so maybe I can let that go. You might want to stop drinking really late at night before your 7 a.m. class. Anyway, yeah.
Well, so you used the basketball thing earlier. You know, because these guys play basketball, they're tall. Whereas you say it the other way around, because they're tall, they play basketball. There is a correlation there.
I love it.
But you're using the same numbers.
All right, so you ready? Behind any analysis you do, I love this. It's trying to self-preservation, right? Behind any analysis you do, whatever numbers you find are just the math saying yes, they do line up or not. Does that mean that they affect each other? Does that mean that one affects the other one, that one affects that there's a third factor? Does it mean it's a coincidence? Could be a coincidence. But this would be part of exploratory analysis. So if I see a correlation, then I might go do some more detailed studies. I'll do some pre-study hours and then give them a test with no studying, and then I'll give them the same people the same test or a similar test after they studied. And then I can do an analysis like in the last section of the hypothesis where I see the difference. And then I can do a real test to see, does this affect the grade? Do you guys see what I'm saying? This would be for exploratory data analysis. I could do a lot of different variables doing this and see which ones looked like they might have a cause and effect relationship, but then I have to go test that relationship. Does that make sense? So that's why I'm glad I got at least a chance to talk about that section 10.4, the one I made extra credit. But that is a way you can say, this is what it was before, then I applied something, and this is what it is now. And that's the kind of test where you can get a feel for if there is a cause and effect relationship. This one doesn't tell you a damn thing about cause and effect. It just says, yes, they changed with each other. As one changes, the other one does too. That's all this says. So it's a really good point. I'm glad you brought that up, because I'm going to continue to enforce that point over time. Just as an example of this, I don't know if you've ever seen this website. You still haven't. There it is. Spurious correlation. So, for example, this is kind of morbid, but they did it by year, the number of films that had Nicolas Cage in it and the number of people who drowned by falling into a pool, and it seems to be correlated. Or how much cheese is consumed versus the number of people who died becoming tangled in their bed sheets. So on one level, people see this kind of thing and they think, well, why do any of this shit? I mean, you lead to things like this. But this is really, really poorly done. Is the scale the same? In fact, the scales measure completely different things, right? So you can scale something up or down and make it kind of match some other graph somewhere in the universe, but you can't just suddenly say, this is examples of how to be careful when you do correlation, right? There's just going to be coincidences everywhere that they just happen to look the same. Does that make sense? So the point of this website is not that you shouldn't do any correlation analysis. That's bullshit. You just have to be careful that you're not finding something that isn't really there, right? I really doubt, oh, this cheese is good. Oh, shit.
I believe it's Nicolas Cage on that.
I don't know. Yeah, maybe. It's like, he was in how many movies? Oh, my God. Depends on how you feel about Nick Cage. Anyway, so if you want to, it's just spurious correlations. And divorce rate in Maine.